Hi, my name is Mr. D, and today I want to take a look at multiplying radical expressions. So we have write the following expressions in simplest radical form, and we have two problems to look at, but there's a few ways you could do these, but I'll focus on one that's kind of straightforward, that works the best. So we're looking at radical 8 times radical 12, and the simple way to do this is to just multiply the numbers underneath the radical and combine them into a single radical. So if we're looking at radical 8 times radical 12, we're looking at 8 times 12 is 96. And now this gets us started. Now this is a problem of simplifying radical expressions. So if we look at 96 and we want to break this down, we're looking for a perfect square factor of 96. So if you look through the list, we have 1, 4, 9, 16, 25, 36, and so on. We could project that 16 will divide into 96. And if you have a calculator, you could do 96 divided by 16 and it should give you 6. So this tells us we could break this down into 16 times 6. So the strange thing about multiplying radicals is that you'll turn two radicals into one radical, and then once again you'll break them back down into two radicals. But the goal is to have a perfect square factor. That's what we want. So now we could take the square root of 16, which is 4. So we have 4 radical 6 would be the simplification of radical 8 times radical 12. And it's in simplest radical form because radical 6 cannot be broken down any further. 3 times 2, 3 and 2 are not perfect squares, so that tells us we're done. So now we can focus on the second example. We're looking at radical 30 times radical 40. And once again, all we need to do is multiply the numbers under the radical, and we could combine them to a single radical. So we think 30 times 40, if you want to do this mentally, 3 times 4 is 12, and we have 2 zeros, so 30 times 40 is 1200. Now most students, when they break this down, they look at the 2 zeros and they say it's divisible by 100. And if we look down the list of our perfect squares, we'll see that 100 is in fact a perfect square. It's 10 times 10. So most of them will rewrite 1200 as 100 times 12. And for the students that get this wrong, they simplify here. They say the square root of 100 is 10, and they stop here at radical 12. But remember, you have to break it down into simplest radical form, which means you have to keep breaking it down until you can't find any more perfect square factors. So we could break down, we have 10, and 12 could be broken down to 4 times 3. So now when we take the square root of 4, we just rewrite our 10. We have the square root of 4 is 2. So we have 10 times 2 times radical 3. And 10 times 2 is 20. So our final answer to the second example is 20 radical 3. But notice that after we multiplied, it took us about 4 or 5 steps to get to 20 radical 3. And now the reason that this occurred is we could find a bigger perfect square factor. You're not expected to know this, but if you zoom down the list, another perfect square would be 400. So this tells us that solution 2, another way we could solve this is we could call radical 1200, we could call it radical 400 times radical 3. Once again, we're writing our perfect square factor 400. And now we have 400 times 3. But now this simplifies. The square root of 400 is 20. And look how quick we're finished with this. It's over in 2 steps. So the reason why it'll take us a long time sometimes is that we won't pick the biggest perfect square factor, but don't be alarmed because you'll still get the same answer. You just got to make sure that you keep reducing the radical until it's in simplest radical form. Okay, well this is going to conclude this video on multiplying radical expressions. Thank you all for watching, and I hope that this was helpful.